So with this video, I want to go over section 4.1, polynomial functions and modeling. In this section, we're going to be looking at a polynomial function and just looking at what is called the leading coefficient. Leading coefficient in the leading term of every polynomial. So pretty much the first part of the function given. So let me just enlarge this. So just to give you a few examples, and this is going to be considered to be the leading term that we're going to be focusing on in section 4.1. If you just are given a function and it just has a number, it's considered to be just a constant because if you have understood x to the 0, anything raised to the 0 power is 1. So for a constant, the degree is 0. So the degree is what you're looking at is the exponent. The leading term is just going to be the first part of the function, whatever comes first, and it has to be in descending order. So descending order means 4, 3, 2, 1, and then 0. And then the leading coefficient is just whatever is in front of that the term. So for a linear function, we just have 2/3 x plus 5. So this understood 1 to be up here. This is going to be the leading term. So the degree is going to be 1. The leading term is the first part of the function. And then the leading coefficient is just 2/3. The number or fraction does not matter in front of the variable. Quadratic is you have the square. So here's the descending order. We have 2, 1, and then 0. But since this is the leading term of the function, the degree is going to be 2 because of the exponent. The whole thing is going to be the leading term. This is what we're going to be focusing on. This column right here is what we're really focusing on a lot in this section. And then 4 is the leading coefficient because of the 4 is in front. The last two is the cubic and quadrate. And we have 3 for the first one. That's our degree. 4 is going to be the degree for this one. The leading term, these are the first two that come in front, and then the leading coefficient is just 1 because it's always understood to be a 1 even though we don't see it. So again, this is what we're focusing on, the first part of the function. So for a quadratic function, this is a little bit of a recap, but we can get a lot of information from just this function x squared minus 2x minus 3. We can get a lot of information here to graph it, find out the intercepts, the zeros, and everything. So the first thing we're going to do, if we want to find the zeros, remember we have to go back to our roots and factor this polynomial, this trinomial, into these two factors here. So once we do that, we set this part equal to 0 and then set this part equal to 0 to get our 0. So x plus 1 equals 0. Solve for x, we get -1, or we can just change the sign. And then x minus 3 equal to 0, move the 3 over by adding, and then we have a positive 3. So these are considered to be my zeros. Now, how many zeros are we supposed to have for this function? Well, the degree will pretty much let you know how many zeros you will have. The zeros is another way of also saying the x-intercepts. So what are x-intercepts? Is when this graph actually crosses the x-axis. So here we have our first one, and here's our second one. And they come from the zeros we found. In order to label this ordered pair, because the intercept is a ordered pair. So if the directions ask for find the zeros, you can just put -1 and 3. But if it asks for the x-intercepts, you have to put it as an ordered pair with the 0 in the y coordinate. So -1, 0, that's where it came from, and 3 here. So also too, I noticed in my MathWise Plus, please remember to put this little comma to separate these two answers. If you just put in the parentheses -1, 0, and then parentheses 3, 0, those are the right answers. But if you don't put this comma, my MathLab is going to mark it wrong because it doesn't know how to separate these two. So just make a note of that when you're going through my MathWise Plus. The y-intercept is pretty easy because it's pretty much the constant, the last term in the function. So -3 is going to be the y-intercept. And again, make sure it's in the order pair. So for y-intercept, the 0 goes in front. For x-intercept, the 0 goes in the back. Another way of looking at the y-intercept is if you plug in this 0 for x, plug 0 here, plug 0 here, 0 squared is 0, minus 2 times 0, which is 0, gives us a negative 3. So pretty much you can just put your hand or finger over the x's, because once you plug in 0, they're going to go away anyway. The final, the whatever's left over is considered to be the y-intercept. So pretty much the last number in the function is going to be the y-intercept. If you go back to chapter 3, when we talked about how to find a vertex, remember the vertex is the lowest, either the lowest or the highest point of when the graph changes direction. So we're coming down, down, and it changes direction here and shoots back up. So this is going to be considered to be the vertex. And in my other videos in chapter 3, it will explain how to find this vertex. So once you find the vertex, the minimum, because it's on the bottom, this is the minimum access point right here, will be 4 at when x is 1. So when x is 1, the minimum is going to be negative 4. Then it changes directions and go up. There is no maximum because remember, a maximum has a frowny face. So this is considered to be a happy face. And then you have a frowny face. If you have a negative in front of this term, it'll be a going downward. So that would be the maximum point up here. So there's no maximum vertex anywhere on this one. Domain. So how far left does this graph go? So yeah, it kind of stops right at the negative 3 marker here. But because of these little arrows, it kind of continues on in this direction forever. So that's why we have negative infinity. And then how far right does it go? It goes all the way in this direction to the left to positive infinity also. The range is how far down does it go? So it kind of stops if you look at the y, because domain deals with the x left and right. Range deals with the y up and down. At negative 4 is where how far down it actually goes or stops. So does it touch it at 4? Yes. If you draw an imaginary line going through negative 4, this dot right here will touch that imaginary line. So that's why we put a bracket. And then how far up does it go? It goes to positive infinity. It just continues on up, 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 up. So that's all we have infinity here. And infinities always get parentheses because we can't, a bracket means you include the number. Well, we can't actually include infinity because infinity is not a defined number. It's just it continues on forever. So that's why we put parentheses around that. So a cubic function, so how many x intercepts do you actually have for a cubic? Well, we see it crosses 1 time, 2, and then 3. So where do we get that 3 from? Remember about third degree? The 3 kind of gives us a way to let us know how many zeros or x-intercepts because of that leading term or the degree of this polynomial is going to be 3. So if you do factor by grouping, and I'll show you how to factor by grouping in one of these examples here, but we want to group the first 2. We want to find the GCF and then group these here. Now, if it doesn't work for this particular one, it does not work. You can't do factor by grouping, but if you have a term of 4, that's when we want to do factor grouping to get to here. But for this particular one, factor grouping will not work. So this is where we have to use the calculator. And again, I will show you that in just a bit, how to find your factors here. The negative 4, which comes to the opposite of here. The negative 1 comes to the opposite of this x plus 1, and then x minus 3 is the positive 3. So here are my intercepts. Remember, again, put the zeros and put a comma in between each one of them. X-intercept, again, that last term here, which is going to be the negative 12. Put a 0 in front. And then because of this one here, this one actually has a minimum and a maximum because here is a maximum point here because, again, it goes it's coming up, 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 and then it comes back down. So when it changes direction, that's our vertex. And then we have another one for this one here when it's a minimum. So the minimum down here. Again, all real numbers, how far left does it go? So it goes on to the left forever, and then it goes over to the right forever. And then how on the range, how far down does it go? It goes down forever and then up forever. So this is going to be a cubic function. So here's some more examples of some polynomial functions. So we have squared, it goes up, constant, a cubic, and then this is a quadratic. And all these is considered to be continuous. There's no break in the action. It continues, and there's no sharp corners There's a smooth reaction traveling path going from left to right for each one of these. So all these are considered to be continuous because you have that smooth transaction. There are no holes, there are no breaks. It's all smooth, no sharp corners. That's how you know a function is continuous. So these are some non-polynomial functions. Here's a sharp edge right here. So it comes left and then shoots back up to the right. There's a sharp edge here. Here we have it starts at -1 and then kind of continues on in this direction here. Here's a little sharp here. Here's a break in the action. It comes down, shoots back up here on an imaginary asymptote, which is another section altogether. And then it comes down here. So these are this is continuous. This is smooth from left to right. There's no break or anything. I can take my little mouse cursor and go straight along here without any breaks. However, this is a discontinuous function because we have a break in the action. I kind of come from here, jump up to here, come smoothly this way, but jump back down here. When you have that break in the action, that's when we get a discontinuous function here. And then another discontinuous function is when we have that smooth traction, but there's a hole right here. Because of this hole here, that's why it's discontinuous. So let's talk about the leading term test. Well, again, what we're doing is looking at the first leading term of the polynomial function, and we're going to talk about its behavior. Even degrees, so when the exponent is an even number, you'll notice that it's coming from the top and then it's going back to the top. So when it starts in the same direction and ends in the exact same direction, that's when it's known to be even. So this is coming down, it's going down, this one's going down. So this is going up, this is going up. That's how you know it's going to be even. For odd terms or exponents, it won't become from a down position, it goes back up. So these two are going to opposite directions. So anytime you see a graph going opposite directions, this one's going down, this one's coming up when it finishes, you know it's going to be an odd term for the exponent. Same thing here. Now the direction, again, if the leading coefficient is positive, then because it's greater than 0, then we know it's going to go in the positive direction. If it's a negative, it's going in the negative direction, so downward. So that's when it's less than 0. So all numbers greater than 0 are obviously a positive. All numbers that are less than 0 is going to be negative. Same thing here. I'm starting from the left. I'm ending where? I'm ending in the positive direction. It's going in the positive direction. So that's why we have a positive leading coefficient. For a leading coefficient with a negative or less than 0, you notice when it finishes, it goes down. It continues down. So always read a graph from left to right. But since it's going down, that's why we know it's going to be a negative. This little squiggly part right here, this little portion, there's some more action going on. So anytime you see this here in these directions, this portion here, it might be going up and then back down and up or whatever the case here. So I just want to kind of show you the starting and then ending and not necessarily worry about the middle part of the graph. So some more examples. So we have even. See how they both ending up in the same direction going up? That's how you know it's even. Going down, even. Again, going up, there's an even, and then down, down again, even. So start low, go high, odd. Start high, go low. Leading coefficient is odd. So again, the odd, you start from one direction, go in the opposite direction, and finish in the opposite direction. That's how you know all these here are odd functions. And then again, if you see the negative, that's why it's down. A positive is up, and here's another negative here. Now understand this one here is not necessarily in descending order, but again, if we rearrange it, put this negative x10 to the front because that's going to be the highest degree, because you always want to end up in descending order. So 4, 3, there's no 2 here, but 1 and then 0. The leading coefficient is always going to be the highest degree. So make sure you change the equation around so you'll know and put this first. So you know that's going to be considered to be our leading coefficient term. So for this one here, we wanted to look at each one of these graphs, A, B, C, and D, and figure out by just looking at this, just the leading term or the in the function, which one of these goes with which. So for 3x to the fourth, it's considered to be graph D because we have a 4 that is even. So we know it's going to be, we can eliminate this one and this one because these considered to be the odd ones because they're going in different directions. So even ones here, but because this part here is a positive, remember our happy face when it's a positive. So B has a negative, so we know it's going to be going down, start from the left. So this one here ends up, when it finishes, going positive. This one here, when it ends up, it goes negative. So we know this one here is going to be graph B. And the term here is odd, so that's why we're going to either choose A or B for this one, because of the negative, it ends up in the negative direction. So the same thing for the last two. We have an odd, so that's why it's A. So it's going to the positive direction with a positive turn, negative going down for C. So let's kind of connect some of these dots of what we learned so far. So once you factor, using a function or setting equal to y, both are exactly the same thing. If you have a function here, we're going to set these both equal to 0 and solve. So once we factor and solve, we set them both equal to 0 like I discussed at the beginning part of this slide. Move the 2 over by subtracting, we get x equals -2 and then x equals +4. These are considered to be my zeros. So how many answers do we have? We have 1, 2. How do we know how many answers is? Because of the degree of this polynomial, which is 2. So if you plug this -2 back in for here and here, this should all equal to 0. Same thing before. That's why these are considered to be my zeros. These -2 and 4 are the same thing, and when we find the zeros, is the same thing as we were finding the x-intercepts. The only difference is, again, you have to put it as a ordered pair, where the 0 goes into the y coordinate spot. Same thing with a cubic. We're going to have 3 points when it actually goes through the x-axis. So like so. And for this one here, again, if you can't factor by grouping, where I'll show you how to put this in the calculator. So before we get, the next topic we're going to talk about is multiplicity. Multiplicity, looking at this part here, is pretty much, we're going to find out the first thing you need to figure out is what are the zeros for the function. So here, set this equal to 0. The answer is going to be 2. This one's going to be 2. This one's going to be 2. This is going to be -1. So here we have how many 2's? 1, 2, 3. That's why we have this as a cube. Then how many x plus 1's? We have just one of these. So for my 0, for x minus 2 is 2, and it has a multiplicity of 3. So it just pretty much, multiplicity is how many times does this occur? That 0 occurs. 1, 2, 3. Multiplicity of 3. For -1 as the 0, how many times did -1 occur? Well, just one time. You want to see it one time. So it has a multiplicity of 1. -1 has a multiplicity of 1. 2 has a multiplicity of 3. And that's all that it is to multiplicity. It's just how many times do you see that 0, once you find the answer for 0, occurs in that function. Now notice here, all the problems in my MathFast Plus is not going to give you a perfect factors. There'll be problems where you have to take the polynomial and factor to this part here. But for these particular examples here, because they're already factored for you, we know the 0 is going to be 1 for this one, and that occurs how many times? 2. The 0 for this one is going to be -2, and how many times it occurs? 2 also. So for 1, the multiplicity would be 2. For -2, the multiplicity would also be 2. All right, so here is where we're going to be doing factor by grouping. So let me take you to the example of how to factor by grouping. So here's the function here. The first thing we want to do is group the first 2 together. So let me group these together. There we go. And then I'm going to group the second two together, like so. So what we're looking at is we're going to find the pretty much the GCF of this first part. What can I take out of the first part and the second part and put it on the outside? Well, here, to find the GCF of this one here, you want to pick the lowest term. The lowest term here is going to be x squared. So I can pull out an x squared. And what does it leave me with? 1x here minus the 2. For the next part here, I'm looking at this first part here and the first part here. So this part and this part here. And then I'm going to determine what can I take out. For this particular one, I can take out a -9. So let me put my -9 on the outside. And then that leaves me with, in the inside, x minus 2. So how do you know if you're doing a factor by grouping right? If you notice here, these two parts here should look exactly alike. That's how if you know if you're doing it right or if it can be factored by grouping. So once you do that, we just write this here, this part here, just one time. So x minus 2. Excuse my pen, it keeps changing back and forth on me. So x minus 2. And then whatever's left out in front, it's considered to be the first factor, x squared minus 9. So again, what we're trying to find here, we're doing factor by grouping to find our zeros. So here, this is called a difference of squares. So this can be factored again to x plus 3 and then x minus 3. And then we can just drop down to x minus 2. So this one here, the 0 is going to be -3. This one here, if I set this equal to 0, this is going to be 3. If I set this one equal to 0 here, this is going to be 2. And if this question was to ask what is the multiplicity, well, there's only one -3, so that's multiplicity of 1, multiplicity of 1, multiplicity of 1. So there's only one time it occurs. So my answer for this one here for the zeros, -3, 3, and 2. So 2, -3, 0 for my here. So let's go to the next one. So for this one here, if I factor this part here, the factors to be x squared minus 5, x squared plus 9. Now be careful with this part here. This one looks like that you probably want to do x minus 3 or an x plus 3, but this is not considered to be a difference of squares. There's no such thing as a sum of squares where you have an addition. So you can't factor like we did before in the last part to x minus 3 and x plus 3 because here is a difference of squares. This is, you could take the square root of this one, the square root of 9, and get these two here. So be careful when you see something like this. This one here cannot be factored. This one cannot be factored either because this 5, you can't take the square root of 5. So we just go ahead and set both of these equal to 0. So I set the first part equal to 0, add the 5 over, get rid of the square by taking the square root. So I have plus or minus 5, square root of 5. Bring this 9 over by subtracting. And then for here, because we have a 9 in the a negative in the inside, when we take the square root, I have to remove this negative by making it an I. And then the square root of 9 is 3, so plus and minus 3. So here are my zeros, plus the square root of 5 minus the square root of 5 plus 3i minus 3i. So how to put this in the calculator to find the zeros? Because obviously for this one, if I group these together, these will not, you can't do factor by grouping with this one. So when you can't do factor by grouping, we go over to our calculator. and we type in the function, go to your y equals, clear out what you have, and we're going to put in the function 0.1 x raised to the third, slide over, minus 0.6 x raised to the second, slide it over, and then 1, oops, forgot to put in this, then minus 0.1 x, and then plus 2. Then drop down to the second one, and again, we're trying to find the 0, so I'm going to put a 0 for the second one. Now my calculator is going to show the first graph being blue, the second graph being red, which is the line on the x-axis. If you don't have a calculator that shows different colors, maybe you have a old 83 calculator, it's fine. You still put in the 0, but just understand your red marker will be on the x-axis. So we hit zoom 6. So here's the first one here. So the ones that don't have the colors, you have to know that when you put in your 0, the line is on the x-axis, even though you probably can't see it. So how many answers will we have? 1, 2, 3, because they have that cubic going on. So we hit second trace, and we're trying to find out where it intersects at. I know maybe some YouTube or something says you can use a 0. I just like using the intercept, putting that 0 in for y2, and then doing that intercept. Both will give you the exact same answer. So I'll go over to where I think it meets at. It doesn't have to be exactly on it. I hit enter 3 times. 1, 2, 3. And my first 0 is going to be negative 1.68, blah, blah, blah. Then second trace to go back and get your next one. So I'll slide it over here. Now notice what I did. I had to go back and hit second trace to go to here. You can't just slide your cursor over and hit enter 3 times. It's not going to work. So we hit enter 3 times. Here's my next answer, 2.15 with some more numbers here. Then MyMathLab 2 will also tell you, just make sure before you type it in, look at the part in blue, and it would let you know if you need to round to a certain decimal or place value. So let's go get the third one. Remember, again, don't just slide it over to here. You don't want to do that. That's a no-no. You have to hit second trace and then go back down to number 5 again and go over to the graph and then hit enter 3 times. 1, 2, 3. And that's going to be our third answer. So those are my zeros for each one of these answers. Now, if you get to an equation where the graph you can't see them, you might have to do zoom in or zoom out, or you can hit zoom 0. So go down to 0, and then the calculator will actually fit it into your window screen. So play around with the zooms in, zoom out, the zoom fit, stuff like that if you can't see the perfect shape of where they cross the x-axis. So here are the answers that I found in the problem. And here are the directions here. So these are my directions. This is what you put in. For this one here, I guess the directions were to round to 3 decimal places. So 1, 2, 3. So this concludes section 4.1. If you have any questions or concerns, please let me know.